All right. We're going to do the slope formula, but we're going to review first finding the slope the way we did last time with the picture. And so you drew the nice little right angle, and we counted 1, 2, 3, 4, and we wrote the number 4 here. We counted 1, 2, 3, 4, 5, 6, 7. And we wrote the 7 up there. So when we wrote the slope, or we wrote the number that put in front of that y equals mx plus b thing, this number right here, you put that into the formula. How did you write it? How did you put, what number did you put? Did you say 4 or 7 or 4 over 7 or 7 over 4?
Over 7.
We actually did the 7
over 4 because we're
over 4. And does this go downhill, or is this a negative or a positive?
Negative.
It's a negative, okay. This is called the slope. And that's what we're going to talk about today, is the slope. It's how slanted the line is, okay. Negative means it goes downhill, and we have values for this. And I want you to notice that when we did this, you wrote the values that go up and down on top, and on the bottom you wrote the numbers that go side to side. Okay, so this is the side to side. You put those on the denominator, and you put the up and down part on the numerator. Okay?
Okay.
All right? And so instead of us using the words up and down part and side to side part, mathematicians are a lot more technical. They have vocabulary for that, okay? And so the up and down part we call the rise.
And the run.
And the run, okay? And on an x and y axis, which one is this? Is this the rise or the run here?
The run.
The run, and it's the x-axis, okay? And that rise on here is the y-axis. And so the slope is the rise divided by the run. And so if we're going to find a formula, if you knew this point right here and this point right here, we could actually, without drawing a picture, put it into a formula to find the slope. And that formula would have y values on the top, because we have the y values on the top, and it'll have x values on the bottom, because we have x values going on the bottom. Does that make sense so far?
Yeah.
Here's the slope formula. I tell you all this stuff first because when you first see it, it's going to look really ugly. But if you can kind of look at it and know why the formula is that way, it's going to be easier to memorize, okay? So the formula starts with the letter M, because they use M for slope, just like we did over here in that formula.
Wouldn't it be like S or something?
Yeah, that's a good question. S for slope. And if you start writing S's too often, they start turning into 5s. And then then it kind of gets confusing.
So where did they get the M?
I don't know where they got the M, but I
like
know what I do to help myself remember it. I don't know where they got it, but I think of the word mountain, and mountains have slopes. That's how I remember it, but I don't know where they got it from. Maybe I should look it up on Google somewhere. Start with M and then equals. And we have the y, remember we said the y values is going to be on the top and the x values are going to be on the bottom, right? And so to find those values over here, to find out how high I've gone, I take this y value and I subtract it from the y value down here so that I can find out how far I've gone up and down, okay? So I take one of the y values and I subtract the other one from it. And we put the little numbers at the bottom down there. Those are called subscripts. They just say I take one y value and I subtract the other one.
Oh, okay.
And I do the same thing with the x's. I take this x value and I subtract it from that x value, and I'd have how far it went over. So we're going to take x2 minus x1, okay?
Oh, okay.
Now, it doesn't matter if I put a 1 here, or I could have written this like this. I could have written it m equals y1 minus y2 over x1 minus x2. Most textbooks are going to have it written like this one.
Okay.
But as long as we stay consistent on which x values we choose and which y values we choose, we can choose any one of them. Let's do some examples so you can understand. So if this time we don't have a picture. We have the ordered pair 4, 3, and then other ordered pair 12, 5. Now you could get out your graph paper and graph these and then draw your triangle. But with this new formula, we don't have to. So I'm actually going to copy this formula here to bring it over so that,
Whoa.
see if I have that again. I'll just copy it instead of cut it. Copy it. Paste it, make it little so we can use it. All right, there it is. It says that my slope equals the y value subtracted on the top. All right, so I have to decide which one's my first and my second, and I like to have positives. So I'm going to make this my 2,
Yeah,
and this one my 1, so that I can take 5 minus 3.
Yeah,
Okay?
I think so too.
All right? And it wouldn't have mattered if I put those 1 and 2s in different spots. But since I said we're going to do y2, this is the y2 because that's the y value that's under the 2. So it's a 5. This is the y value under the 1, so it's a 3. You with me so far?
Yes.
Okay. And so this is now the bottom says x2 minus x1. So I have this 12 is my x2 minus the 4 over there.
Okay.
Okay, now we just do the math. 5 minus 3 is 2. And 12 minus 4 is
8.
We need to reduce this fraction.
Yes. 1/4.
1/4. I know that my slope is 1/4.
Oh, that's not
Okay,
bad.
let's do another one. They're actually going to have us turn it around. What if we would have called this the 1 and this the 2?
It would have been negative.
Let's see. So we're going to do a slope. So it says y2 minus y1. So let me get my eraser out. And I like to do the underline so we know what we're talking about. All right, so y2 is the 3. And y1 is the 5. You're right, we're going to get some negatives there.
Great.
And then my x2 and x1, here's x2, which is 4, and x2 is 12. Okay? I'm going to have a negative 2 here and a negative 8 there.
So that means we'll have a negative 1/4.
What's a negative divided by negative?
Oh, positive.
Positive.
So we'll still get positive.
We'll still get the right answer. That's why over here I said, it doesn't matter how I write it. As long as we do consistently with our x's and y's, we call one of them a 2 and one of them a 1, and we consistently take them the way they're supposed to, we'll get the right answer.
Oh,
so it
okay.
won't matter which one we pick, 1 or 2. Okay?
Oh, okay.
Let's see what we got. Let's do another one.
They're not going to change it up on me.
No, the formula's going to stay that way.
Ah,
Okay?
good. I hate it when I finally get the idea and then they're like, okay, now we're showing you a new way to do this.
No, same way. Let me paste the formula again. We'll make it little, leave it up there at the top. There we go. All right, so we're going to do, I don't care, you choose. Which one do you want to be 2 and which one do you want to be 1?
Okay, wait, I gotta think about this. 1 and 2.
Okay, so you want this one to be 1.
Mm-hmm.
1 and 2. Okay. So for the thing that most students mess up on is they put the x on the top because we always do x's first, but it's always y's on top. So we're going to do y here. So we're going to do, here's y2 because it's under the 2. And here's y1. Do you understand that?
Mm-hmm.
Okay. Now we need to do the x values. It says x2 minus x1. And since we said this was the 2's, what number are we picking?
8.
Very good. And then minus x1, which is
4.
Be careful.
Negative 4.
That's a big deal. So make sure you put the negative 4. We're already a subtract with the formula, and there's a negative there. That's going to be a chance to make a mistake. Okay, so be real careful. So I have a negative 7, and I subtract 2.
So it would be negative 5.
No, but you're right. It's a negative.
Oh, wait, yeah. It would be 9.
Yes. Okay. What does this negative do?
It turns into a positive.
Yes, I'm going to change color so
So it would be positive 12.
yes. So we're going to do positive 12. This reduces, stays negative. We can take a 3 out of both.
Yeah, so it would be negative 3 over 4.
Negative 3 over 4. Very good.
Oh.
Let's do one more. We're going to get our formula over here like we've been doing. And we have an ordered pair of 5, 1 and 5, 8. Okay. So, which one do you want to be 1 and which one do you want to be 2?
We can just do 1 and 2.
Okay. All right, so we're going to do y2 minus y1. Which one's y2?
This one.
Yes. 8, and then which y1?
1.
Okay. x2.
5. I guess it doesn't really matter because
It doesn't. You're right. Okay. So I'm going to have a 8 minus 1 is 7, and 5 minus 5 is 0. There's a problem here. Whenever you have a 0 in the denominator of a fraction, the math world could fall apart. So you can't divide by 0. So it's called undefined.
Oh, okay.
This would be one of those lines that had a slope like up like this, straight up and down, where there is no slope. So you could call this undefined slope, or you can also call this no slope.
Yeah.
It is different than a 0 slope.
So before, if you're like working it out and you see you have the same thing, you could just not work it out, right?
As long as both of those things are the x's.
Yeah.
If we had done this the other way around, and we would have done 1 comma 5 and 8 comma 5,
it wouldn't have
it wouldn't have been a problem. Because we would have, we call this 1 and that one 2. So our y2 is 5 minus 5. It doesn't really matter because they're both. But x2 is, which one?
This one.
Yes, 8.
Should be 7.
Yes, so we would have 0 over 7. Not a problem.
Yeah.
0 on the top is not a problem. What is 0 divided by 7?
7. 0. I mean.
0. This would be a 0 slope, and that is possible. This one has a no slope whatsoever. So the hard part is, but 0 means nothing, so you think nothing, no. That seems like they should be the same thing, but no slope is one of the kinds that go straight up and down. A 0 slope is the kind that has a slope going straight across like this. Okay, that's like flat. And there's no. It's a 0 slope. You're walking. You're not going uphill or downhill. It's a 0 slope. A no slope would be one where you'd totally fall off the cliff, die. Okay.
Yeah.
Okay.
Okay.
All right. I think we're done. We've done slope of a line, and we've used the formula. What I would suggest is at the top of your paper, you write this formula at the top of your paper.
That's a good idea.
So that you'd have it there, and you can refer back to it. After a while, you'll just be able to use it without the formula, but if it's at the top of your paper when you're doing your homework, it's easier.
Okay.
All right, we're done.